All right, so let's take a look at question 4. We are given the percent abundance of magnesium 24. We're given the mass of magnesium 24. We're given the percent abundance of magnesium 25. And we're given the mass of magnesium 25. And we are tasked with finding the average atomic mass for magnesium. Now, if you look at the periodic table, we will find that magnesium is element 12. And I'm running out a little bit of room here, but the mass at the bottom would be 24.3. So that's what our answer should approach. So we want to convert the percent abundance of magnesium 24 as 0.7899. We're going to multiply that by the mass, which is 23.9850419. And we're going to add to that, taking into account the other isotope that has an abundance of 10%, so that's 0.1 times 24.9858370. And there's a third isotope that has an 11.01% abundance. That'll be 0.1101 times 25.9825930. And when we simplify this expression, we obtain 24.305. That's AMUs, atomic mass units. We're going to talk about those atomic mass units tomorrow. And that answer correlates really well with what we see on the periodic table, which is 24.3 AMU. So our answer makes a lot of sense. We have confidence in it. We're ready to talk about number 5. So let's take a look at question 5. So question 5 is a little different. We're given the average mass of copper on the periodic table. If you consult the periodic table, you will find that copper has a mass of 63.546 AMUs. This is equal to the percent abundance of copper 63 times the mass of copper 63 plus the percent abundance of copper 65 times the mass of copper 65. Notice the masses are provided to us, but what is not provided to us are the abundances. That's what we're going to solve for in this problem. So I'm going to allow the percent abundance of copper 63 to equal X. I don't know what it is. I need to solve for it. Since I know there are only 2 isotopes of copper, if X is copper 63, 1 minus X must be copper 65 because added together they equal 100%. So now I'm going to have one big equation with one unknown, and it's going to look something like this. $62.929601 times X plus 64.927794 times 1 minus X is equal to the average mass, which is 63.546. 6. So now all I have is one equation, one unknown. I just need to do some simplification. So 62.929601x plus 64.927794 minus 64.927794 x equals 63.546. I'm going to gather like terms. So when I start collecting like terms, on one side I get negative 1.998193x is equal to negative 1.381794. I need to divide both sides by negative 1.998193. And I find that x is equal to 69.15%. Once I convert it from a decimal to a percent, that's equal to the abundance of copper 63. Since they both have to add up to 100, that means the abundance of copper 65 is 100% minus 69.15. So that will be 30.85%. And I've solved for the percent abundances of both of these isotopes.